Well, welcome, Jinha. Really excited for today's conversation and tutorial. Uh, for those listening or watching, we are joined by Dr. Jinha Jung. He is an associate professor of civil and construction engineering at Purdue University and the director of the Geospatial Data Science Lab. He focuses on high throughput remote sensing, geospatial data science, and platforms that turn massive data sets like USGS 3DEP into light USGS 3DEP LiDAR into usable information, including his open source data science platform that we'll be talking about today. Really excited for the conversation. Essentially, what this is going to be is Jinha's going to walk through someone who doesn't have a whole lot of experience using 3DEP in really complicated ways, this guy, and show us how we can get started using the data and working with his platform. So welcome, Jinha. Really excited to have you.
Thank you very much, Jordan. It's my pleasure to have a chance to, work with you to work on this, tutorial. So I'm looking forward to it.
Cool. So Jinha ahead of time sent me over a GitHub link, which I think if that's okay, we can include in the notes of the show so other folks can access that.
Sure.
Um, and we're just going to go ahead and start by, I'm going to share my screen and we're going to walk through a bunch of stuff. This is not rehearsed, so this is all on the fly. So if you are a total noob like me, hopefully you can follow along and start doing some really cool stuff with USGS LiDAR point clouds. So go ahead and share my screen. There we go. All right, Jinha, I am at your disposal.
Sure. So I shared this in a GitHub link with, Jordan earlier. This is an open repository where everybody's going to have an access to. I'm pretty sure Jordan should be able to share this link when this video is, being published. And I only have two files in this repo at this moment, but I'm hoping that we can be expanding this, tutorial into more examples in the future. But Jordan, I'd like to start with, data to science resources in a Markdown file. So can you click? I think you already have this one open in the tab. So let's go to that one. So D2S stands for data to science, and we've been working on this project for almost 2 years right now. I think our first release was 2024 February, and I think this is almost a little bit more than a year and a half, development. And these are the older kind of resources we've been developed, so far. And I'd like to start by clicking the first link, core services, D2S in our main website. And if you go there, this is our main website, has a ton of information about, workshop recordings, documentation link, QGIS and a plugin, Python module, etc. And if you scroll down, we have some information about, what is D2S, why is it special about data to science platform, etc. So I'd like to have this main website, available. And maybe you can go back to the previous tab. That one, that's in a PS2 instance. This D2S is an open source project where anybody can actually create an instance of their choice. And this PS2 is the instance that has been deployed here at Purdue University, where everybody can create an account and actually use it for whatever purposes that you need. And Jordan already created an account, so I'm not going to go through this process. But if you go to the workshop recordings that I'm going to show you later, there's a ton of tutorial example. And also before this meeting, I added Jordan to a couple of projects so that we can demonstrate. So maybe Jordan, if you can zoom all the way out so that we can see all the list of projects, so that I can have very high level kind of. Probably you're getting too excited. So I added him to multiple projects. So can you zoom out a little bit so that we have some the project shown up in Ecuador as well? So maybe I can start from
Oh,
that one.
cool.
So
Okay.
if you click the Tip Tini Biodiversity, this is the project that we collected in Ecuador. And this is a research station where this place is known to be the most diverse place in the earth. And we actually were lucky to be visit this at the location actually last year as a part of X Prize rainforest in a competition, and we collected a drone data over this location. And once you click choose this in a fly, I mean, project that you see in a Jordan left side, you see the multiple flight card on the left. So these are the all the we have 23 flight. We have ton of stuff. But the one that Jordan wants to click is if you scroll all the way to the bottom, there is going to be a multispectral. The second from the bottom, yeah, you see that TBS MSO. If you click that one, then you see that 3 data product shows up. DSM is a service model. Orthomosaic is actually an orthomosaic multispectral data in point cloud. So can you click the orthomosaic? Oh, there. Then you will see the actual drone imagery. And I think, Jordan, if you could just go back to the top-down view, because it doesn't have any height information. So, yeah, from there, as soon as you zoom in, you're going to see in a higher resolution drone imagery start to render at the high resolution. To give you an idea, this is about 170 gigabyte in size. You can zoom in all the way, Jordan, to see individual trees, actually.
Wow, that was fast.
Yeah. And you'll see that high resolution images being rendered. And this is about 2,500 acre of rainforest where you can get this kind of high resolution drone imagery becomes available. Of course, this is imagery generated from structure from motion. Whenever the tree is not staying still, we're gonna see those kind of artifact shown in some part of the tree, but you can see that power this platform where we can see very high resolution drone imagery becomes a value of fingertip.
Awesome.
And you can actually share this with others if you want. I believe, you know what? Can you scroll down the left pane a little bit to see that you have a share button? Can you click that one? So right now, you cannot share, you can only share with the people who has an account on this system because I set your account in a way so that you can only have the read access. But what I'm doing on my end, I'm just, you're not seeing my screen, but I'm upgrading you to a, uh, let's see, owner of the project. Can you refresh this page? Let me see if you can actually go back Tiptini again, scroll all the way down. Also, click share button again. Oh, we can still not share with others, but let me bump you up to the owner. Probably this is an only the owner can do it. So can you refresh this page again? Go back to that same project. Scroll all the way down. Also, click share button.
Oh,
Now
cool.
you can actually share with anyone. So if you just click share current, if you copy file URL, send the link, the other person can actually download to their computer. But like I mentioned earlier, this is an over 100 gigabyte. Probably you don't want others to download it. But if you copy a short URL, and if you can open a private window, if you go to the Chrome, go to the file menu at the top, yeah, and paste that link that you copied. And if you just type enter, then you can see at the top you are not actually signed in, but actually others can see this data set without logging in. So if you just zoom in, then you're gonna see actually in high resolution drone images being rendered as well.
Wow,
So this is
that's
a
really nice.
yeah, very easy way of sharing your data product with others. And we can just do the same thing for the elevation models, and there are more complicated visualization techniques that you can do. But I'm not going to go through this because this is a very brief introduction of data to science ecosystem. One more thing that I like to do is if you scroll, oh yeah, this is the service model. You can just do the same thing if you like to share. Scroll to the bottom, click share button, then share current copy URL, then go to the private window, then you can actually see that this
Wow.
is being rendered. And you can change the color map, you can change the min-max value for the visualization. There's a ton of other customization that you can do. Let's go back to the instance. If you scroll down in the current project, you see that, oh, maybe can you scroll up a little bit? I like to see the 3D point cloud data collected from the drone. And I believe this is a point cloud generated from multispectral, which doesn't have has a, color information at the 16-bit, and this viewer doesn't know how to do it. So, Jordan, can you go back? Um, yep. Then choose Tiptini again. And if you scroll all the way down, I think that there is going to be a LiDAR. Can you, not this one, can you scroll up? What I'd like to see another project that is on top of that one. You see the
Oh,
TVS LiDAR or? Yeah. Can you expand that 3D product? Can you click point cloud? Now you're going to see actually a point cloud generated from the drone. So this is the same thing. Even once you zoom in, you can see more details. So this is an also we are streaming this data set using cloud optimized data format. So it looks blurry, but as you zoom in, you're going to start to
wow.
see more detail. And right click and move your mouse. You can actually
There we go.
turn around. You can see those are in the buildings. And if you like to see the maximum resolution, Jordan, if you click the three straight line at the top left, yeah, can you click that one? And can you click appearance top and increase point budget all the way to 10 million? Yeah. Then start to zoom in and you will start to see more details. You're going to see the main branches shows up.
Wow. This is pretty
And
fast, Jinha.
yep. So because you are streaming everything from our Purdue data center, so this is then also tens of gigabyte. We are not you are not downloading whole data, but you are actually streaming only portion data looking at the resolution that is needed. And plus, since this is in LiDAR, you can do all those kind of measurement if you want. I'm not going to go through it because it'll take too long. But you can actually do the point cloud and actually in a REST data product. I like you to go back to the homepage. I think you may have to refresh this page. I think there's another way of doing it. But can you open up that Purdue engineering mountain? This is a new data product that we start to support in data to science, which is a 3D Gaussian split. And this is actually data set generated from a laser scanner and photographic camera from the ground. Oops. Yep, it is coming up. And we can actually render some location in a very photorealistic way. So it takes a little bit of time, but you will soon have a 3D Gaussian split loaded on your computer. Wow, this is taking longer than I expected. Okay, I think it started coming up. Okay, now you can just use your mouse. You can zoom in and you're gonna see this is not a point cloud in a Gaussian split, but you're gonna see a lot of detail. You
Ooh,
can actually see from
wow.
this in the screen.
See like scratches in the stone.
Yep, yep. And yeah, this is a scan from the surface, so the bottom side is gonna look ugly, but this is a new kind of data type that we are supporting in our this platform. So there are so many other things that we can do with this, but this is some of the very basic kind of way of interacting with this kind of data type on this data science ecosystem. And like I mentioned earlier, we can spend hours and hours to go over all those kind of the features that is available, but we don't have time for this. And let's go back to that list again, the GitHub page where we have all the list of core features. Yeah. So that was in a PS2 instance. And one of the other key component of this data to science ecosystem is in a stack catalog. So if you collect that D2S stack over there, this is an actually in a catalog where you can publish your project to the public. So, once you publish your project to, this stack, then anybody can access these ones. And I think I had some, training workshop, last week where one of my student or, participant was, following my instruction and they actually published the project as a, Canvas 2025 Jinha. They're supposed to use their own name. But if you click that one, you can see that it is not published by me. You see that there is published by someone else. If you see that contact information, it is
Hmm.
published by someone else. It's not me. When I first saw it, oh, did I publish it and forget about it? But it was someone else published it. So you can actually publish your data product over here, but you see that there's 3D collection over there. Actually, Howard Butler worked with the USGS to actually have a stack in a catalog made available on one of the the catalog. So if you click that one, you can see that actual 3DEP item available in AWS and Open Data Program in this collection. But what we added on top of that in Howard Butler's initial work is that we added a the stack API so that people can query this data. So the one way of discovering the stack data from this stack is Jordan, if you can click search at the top left. Yeah, click that one, and you can search for an item. There's in a two tab. Do your searchable collection. If you go up, right? But yeah, choose in that search for an item. You can specify temporal window. You can also, let's leave it kind of the blank so that we don't limit by time window. You can also filter by spatial extent. So can you check the mark? Then now your map shows up. So you can just zoom into the area where you like to find the data set that you want. So let's zoom in. Uh, let's zoom in even a little bit further in. So maybe go to some kind of township kind of level so that we
This is a
can.
Yellowstone data set I saw, right? So should we be kind of
Yeah.
focusing in
So
that
if you like
area?
to search for that one, then you just leave it there.
Okay.
Whatever that, the white, what is that, rectangular box that you see, that's going to be the bounding box that this, query is going to be looking for. And at the bottom, you see the collection over there. You can just leave as an empty. That means that they're going to look for every collection in this catalog. But in this case, we are looking for a 3D collection. So can you click that collection box there? Type in 3DEP 3DEP, enter. Yep. Then now you're going to be only querying from this 3D collection. Let's scroll all the way to the down bottom, then click submit. Then now it will give you all the item that is available over this region that you're interested in. So can you pick any one that you're interested in? Yeah, Grand Teton. I think that one looks good. It is kind of all data set. And if you click, we have, all those, metadata available from on the, right side. So it just has, I think a time of data, this is the actually the date when this catalog item was, created, not the date of, collection. So I
Mm.
think that one is not correct. I think we are not the one who is generating this metadata. We are pulling it from Howard, the stack, catalog. So, that might be something that, we may have to work with, Howard to, make it update. But you see that, expanding this in asset, you can actually open it. I don't know what this open does. Can you click? Yeah, this gives you an actual, the end-to-end format JSON file that has, all the information that is needed. Let's, we go back to the other tab. And copy URL, this will actually let you download to your computer, but this is an end-to-end format, so downloading that file is not going to make sense. But you can actually open this in copsy.io viewer, and you can actually access this one directly from, Hobu's, cloud optimized point cloud viewer. And now you can just zoom in. then you can actually see the point cloud being streamed to your computer this way. And if we go back, close that window tab, and can you click copy URL? And if you go back to the tab where you have a D2S resources, and one that I like to show from the custom build application is that there is a D2S Cloud Optimized Viewer. Can you click that one? So this is an additional application we developed, now and if you paste it any URL that is in a Cloud Optimized data format, either Cloud Optimized GeoTip or Cloud Optimized Point Cloud, you can actually, visualize this data set in this
Wow.
online viewer as well. So this is another way of consuming your cloud optimized the 3DEP data that is available from AWS. And you see a lot of kind of floating point over there. Just to give you an idea,
Hmm.
if you click the three bar over there, can you scroll down and activate filters? Can you click show and hide all and click unclassified? Turn that on and click ground, low vegetation, medium vegetation, and high vegetation and building. And I think a lot of those kind of the point that was floating high up is in a noise. So if you probably uh, check that noise, yeah, you see that, that is the point that is kind of noise. So you can actually, color by, classification. So if you click the material tab at the top, is that not in
Sphere.
the, yeah, that one. You can actually, color by classification at the bottom. Then you're gonna
Ooh,
see
that's
that, yeah,
nice.
which one is in the water, which one is ground. Ground is a brown color, as you can see on the left. Green is a vegetation, and etc. So once you
Cool.
zoom in, I think you can see actually a little bit better some of those point cloud classification done. And probably using this one, you can generate the water layers. You can use a ground point to generate the digital terrain model. You can use vegetation to do the tree mapping and etc.
This is really cool.
Yeah, but the beauty of this one is that you are not downloading any data. You can actually access this data set from the cloud, directly to your computer.
Can you add multiple collections in
Uh,
here?
Not at this moment.
Okay.
But a lot of times you like to, this is too large area, so
Yeah,
you want to, focus on very small area for your application. This is going to be the main part, that second part of our the tutorial here, where you're going to be actually using the Jupyter Notebook example that I shared with you to clip out some of the small area and doing further data processing.
cool.
Okay. So let's go back to the resources tab again, data to science. So we also have a Python module from the data to science. So any data set on data science, can you click that one? Yeah. And we have a Python module where you can install, if you see at the bottom, pip install D2Spy. And from there, you can actually do, accessing all the data set inside of Python. We are not going to do this in today, but if you click, can you scroll up all the way? There should be a guide menu at the top. So if you click that one, you have the many example codes. So for example, you see that I like to find 3D data for my data science and a project. If you click that notebook there, and you'll have an example code where, hey, you're logging into D2S, and whatever drone data set you got, you like to find, corresponding, 3D data set, and you can pull this 3D data from the AWS to your computing environment and doing some additional data processing. So we're going to do some of this actual, query from our stack in the ecosystem in later example, but this one is also available. Let's go back to our data to science resources tab again. We also have a Jupyter Hub instance and running on our ecosystem as well. You know what? Let me add to one more thing on my end so that you can actually log in here. Give me a second. This is a extension, additional resources that we developed. It is not open to everybody because of, of course, some um, resource limitation that we got. But now you can use your, data science email and password. Okay. Then click sign in. And you have a Jupyter Hub instance and being created for your account. And the good thing about this Jupyter Hub instance is that this Jupyter Hub is running right next to the PS2 instance. So if you need to pull any big drone data set to this instance, that drone, the data data read is going to be extremely fast because then we are in the same subnetwork, which is connected with a 10 gigabit network. So it is going to be almost same speed as, having, loading your data from your local SSD drive. So
Wow.
this is the beauty of this and having this Jupyter Lab instance of running on right next to um, D2S in ecosystem. So let's go back to the data science resources and again.
Should I close this out?
Yeah, yeah, we're not going to using that one, unfortunately, because there is some additional stuff that means, and we also have a QGIS and a plugin. And I'm not going to go through this, but if you just click that one, you can install a plugin inside the QGIS where you can actually access all the data set that you haven't access to into QGIS. You know what, Jordan, you already have QGIS loaded, so let's demonstrate this very quickly. Can you go to the QGIS? Then let's go to plugin, manage and install plugin, and search for D2S. You see the D2S browser. Can you click and install plugin? Then close it. Then go to plugin menu again. Then you should see that the D2S browser showing up over there. Let's. Oh, why is not? Yeah, now it is. Yeah, click that one. Now you can just type in your email and password there. Just make sure that you are not exposing your password because this is being recorded.
Um, I'm unable to click into this.
Really?
It's given me like a little
Can you do tap?
bleeping noise. It might be because I'm screen sharing. I wonder if that is a security
Oh,
layer.
can you just close this out? Let's restart the QGIS. I think I have done this many times. It never experienced this one.
Maybe there's something else.
No, I
It
don't
won't
think
let me
so.
engage with that at all.
Oh, maybe because of that one. Can you just try
Uh,
to do it again? Yeah,
oh, there we go.
yeah.
This is the fun part.
We may have to kind of blur out.
Is this my D2S email
Yeah, D2S
and
email and
password?
D2S. Yeah, the same one that you used to log into the PS2 instance.
Oh, great. Actually, this is going to be a little fumbly because I used an automated password
Yeah,
for this.
yeah. I think we may have to kind of blow out this part, later.
Yeah, I think I can
Copy. Yeah,
copy it
at least you
without.
didn't expose that in actual password.
Yeah.
Oh, you know what? There's one more thing that you may need. Yeah, let's click login. You may not be able to log in. I think I know why. Let's go back to your browser because this we are doing this in a securely. So QGIS doesn't know. The authentication technology we use in the backend is JWT token. And this QGIS doesn't know how to authenticate, that way. So we are actually, you're authenticating yourself using, the API key. So you have to create your API key. This is a part that you're going to be actually, expose your API key, but later you can just revoke it, create a new one. So let's go back to data science website, ps2.d2s.org. Can you go back? Yeah.
This one?
Yeah. Can you click your name on the right? Go to your profile. If you scroll down, you see that your API key has not been created. So you just say that request an API key. Okay. So you need to have this in API key. You don't need to copy. It doesn't make it there, but you need to have this in API key before you can actually log in from the QGIS in a plugin. So what
Okay,
I recommend you to do, and after this in the workshop, is that you can always revoke your API key. So can you click that one? That will just delete it, request an API key again, then this will give you a brand new API key. So uh, either we're gonna just blow out this part, we're gonna just use it for this demonstration, but after this demonstration, make sure you just revoke it, request a new API key after this the tutorial.
great.
Okay, so let's go back to the QGIS plugin. Then let's click login one more time. Now you're logging in. Now you see, can you click the project? Uh, Drop down, no, click, go back to browse. So can you click the project? You see those, 4 projects you have an access to. So let's go
Mhm.
to the, Tipitini biodiversity station. Then you can choose a flight. So there's a flight in a menu over there. You see all those, let's choose TBS multispectral all. Yeah, the second one
This
from the top. Yeah. Then you see that the 2 data product available. So if you click ortho and add selected to the map, then now you're gonna see that actual 170 gigabyte ortho mosaic images is being loaded to your QGIS.
Wow, that was really fast.
Yeah, and because of the beauty of this is that we are using cloud optimized data format. You don't have to download the data. You can actually stream your data. You see that the bottom one, the blue bar over there, that indicates that you're actually streaming. So if you just zoom in, you're going to be able to see much higher resolution images being streamed on the fly. So it'll take some time. The reason why it takes
Uh,
longer than the browser case is that the browser case, those rendering is happening on the server side versus, this one is happening on the client side. So we have to stream data set a little bit more. So that's the reason why you'll be able to actually see that high resolution images, being shown on this QGIS directly. Let's give wow, this is a little bit slower than I expected. It'll come up soon. But in the meantime, let's go back to the browser. Maybe, just leave it there and go back. You know, don't forget to, revoke your, API key. Otherwise, someone else can, be act as on behalf of you. Yeah. Okay, so those are the core services from D2S, and based on this, we also developed some custom built application on top of it. So we already look at the cloud optimized viewer. That's the one that we already looked at. Let me do the second one, Indiana Geospatial Data Viewer. So the stack catalog that I showed you earlier has 3DEP as a part of it, but we also have a whole Indiana ortho imagery and the LiDAR data product also available in this catalog as well. So what we did was we built a web application where you can actually compare ortho mosaic data and the LiDAR data, which is also part of the 3DEP can be the side by side. So this is typical
ooh,
county examples. And also, this is the county ortho mosaic, which is in the order of easily 100 gigabyte in the size. But you can see that we can actually stream this data. And if you can, yeah, this is a side by side and a split screen, so that we have just this one. Can you choose? Let's choose some other stuff. Let's leave it as a typical county.
okay.
Let's choose the data product to be a NDHM, which is a normalized digital height model that is derived from the 3DEP data. On the right side, I'm going to also choose the NDHM. So what you're doing is that you see an year. So on the left side, we have a 2018 3DEP
Oh,
LiDAR, and on the right is in a 2013. So if you zoom in the Purdue campus area, at the Purdue
I
campus,
don't know where that is.
if you can just stay there, I believe I should be able to annotate it. Give me a second so that I can give you a cue. So I think this is the Purdue campus area. So if you can just
Wow,
zoom in
cool.
that.
Okay, this looks
And
campusy.
yeah, the part that I want you to pay attention here is, and if you can just stay there, this is the section where we have a new building constructed. So if you can
Okay.
just zoom in further, and just compare what is on the left, which is in a 2018, and what is on the right is 2013. You'll start to see that hey, there's new building
Ooh,
that went up, right? So this is
yeah.
a small house, and that this is a high rise the apartment building that was built up. So you can just actually do this kind of comparison. Yeah, you see there is another building that went down. They just had a new building coming up. The good thing about this one is that now you can actually see LiDAR and the ortho imagery on the side by side. So on the right side, Jordan, if you click ortho data product and choose 2018, the same year, now you can see the actual aerial imagery on the right side, but you see the normalized distance high model on the left side. You can just do this on side by side.
Wow.
But the
This
thing
is
about
cool.
yeah, this thing about this is that you are not downloading any data. Everything's coming from our stack catalog plus, and everything is in a cloud optimized. And you can just do this for any other county. If you go to, for example, on the left menu, if you choose a Marion County,
Oh, I have a curiosity here, Jinha,
sure,
because there's I'm looking at where
yeah,
is it?
you can put the ortho in
This
2018. Was that?
this this tree
Uh-huh.
right here.
Uh-huh.
I want to see that.
Yeah. Then let's put ortho and put ortho in 2018. So you're looking at the 2018 LiDAR. So
So there's a tree
on the
here, and now there's not.
yeah, yeah.
Wow.
But you can see the beauty of this one, where
Yeah,
this data set becomes very accessible, and you can do this for whole Indiana, essentially. But this can be expanded to other state if needed.
awesome. Okay, so
So this is the one. I mean, this is first one. Let me go to the. Can you go back to the resources tab again? Let's close that out. And we also developed another application, which is called the Live On CHM generator. If you click that link, we also have a source code available on this GitHub on the right side. And this is another web application we developed where all the 3D data set is collected during the leaf off season. But most of the natural resources or forestry scientists, they're interested in leaf on data. So what we did was, we trained our AI model based on 3D, which is leaf off, and all the neon data during is collected in the leaf on season. We tried to find the data set that is collected in the same year. We generate the CHM from the 3DEP, but we train our AI model to replicate what is the 3DEP, I mean the leaf on CHM data set generated from the neon site. So once we train
oh,
this model, then now we can go anywhere in the United States because we have the 3D data coverage from our state catalog. We can apply this in a pre-trained model to generate the live on CHM. So this is the web application that we developed built around those in a pre-trained model, and we can go anywhere. So let's pick, you pick the location that you like to go. You don't have to pick from the top. So let's zoom out. Let's go to the area. I think this one works very good over some residential places because we are also masking out some the buildings during this canopy high model processing. So also Jordan, you and I never scripted this, so you're picking your own places on your own,
yeah.
right? So let's zoom in, and usually I like to have a block of some of the residential area. Try to pick the places where we have some houses and trees. Yep. And what you can do here is now you can just pick click around the map to pick the boundary. So can you just Oh,
Ooh, where did
that's
that
too
first
much.
point come from?
Probably had a, the button click somewhere else. So let's click the, on the left side. Yeah, let's zoom in again. And you may have to click that one. Let's not try to be too big because this is taking a little bit longer. So try to pick the area. Yeah, I think that should be a good size. Click the first point that you click. They should close up that. Now we just set our area of interest. We trained this model with two different model, one with a LiDAR only, the other one with a LiDAR and spectral. So let's choose a LiDAR and spectral because spectral information can help you a little bit better. So once you choose a LiDAR plus spectral, you can click the 3DEP drop-down menu at the top. It will give you, oh, this is the location we don't have a 3DEP data available from the
Oh
AWS
no.
open bucket probably. So probably we have to go to some other place.
Okay.
Let's delete that boundary again, or just reload it. Let's go somewhere else. Just to give an demonstration, let's work on this and city that you're in, because maybe you can just or
Okay.
go anywhere. Yep, yep. Just from here, you just click through some small area. I think it was enabled by default, so you just click it again. Now choose the LiDAR plus spectral and choose a 3D first. You see that we have a 2020 LiDAR and choose native imagery. Since this is 2020 LiDAR, trying to pick the one that is closest, that the last number is the year month. So let's choose the second one from the top, which is 2021 November. Yep. Then the submit job. And what it is doing is that this web application is pulling 3D data from the AWS and OpenBucket, native data from the Microsoft and Azure, and that they just clipping this data set over this region that you specified, feed it into our pre-trained model. Then this will output a canopy height model after eliminating all these buildings, and you're going to be able to see the actual result showing up in this screen right now. See that?
Hmm.
This is an actual canopy height model that is being generated. And if you click the NDHM, this is an actual normalized digital height model. You see all those buildings there. Can you go back to the general CHM? Yeah, doesn't have a height information yet, so it works looks in the best. So if you go to the 2D building, these are the buildings that is detected from this pre-trained model. And if you click the 3D building, it also adds a height information to it. You can
Ooh.
see that. And this whole application is built on that data science ecosystem the architecture where you are not downloading any data, but pulling all this data set from the cloud. But one of the key input to this the custom application is 3D data availability from the AWS and Open Data Bucket. Okay, so let's go back to the menu resources and again. I think there's only a couple more that I like to cover. Indiana Hamilton County Digital Twin. You know what? Before we do that, let's go to the other one. I think other one, seeing other one will be a lot easier. So let's click the Illinois Cook County 3D mapping example. I think Jordan, you have seen this in our the NIST meeting earlier. But
Mhm.
basically, what we're doing is pretty much the same thing as the LOG leaf one generator application, but we just apply this pipeline at the county level. So we just have a building layer the canopy layer extracting out there. You can just it looks like there's nothing, but once you start to zoom in, you will see that actual buildings and trees are being segmented out. So zoom in even further, we'll see that all those the information is generated from there. And this is not only just images, you can see the actual the scale on the left and right. Greens are in the height of the trees and reds are in height of the buildings. And this we're just simply pulling this 3D data and nape imagery from the catalog to generate this outcome. And if you go back to the list, we have example for Cook County, we have an example for New York, we have an example for Denver. And I think if you go to the Denver one, I think there's some interesting one that I can show you. Maybe you can actually go to the other cities later.
So
And
these are pre-processed, right, Jinha?
this is pre-processed, yeah.
Okay.
But using the exact same pipeline that I showed you earlier. But the
Yeah.
data set is coming from AWS and the Microsoft Cloud. And if you see the top left part, we also had the land cover layer, which is the actually 5 classes land cover layer we generated using this in the same process. So if you go to that the green park area, on the one that I meant here is, give me a second, this part here, you can just see, oops, can you zoom out a little bit? I think there are certain section where I can showcase some, can you zoom out a little further? Yep, can you stay there so that I can just point where what I mean by this is, this section here, okay?
The zoo.
Yeah, but once you zoom in, you see the water, you see those in the vegetation area, impervious surfaces in the buildings and the trees. This isn't 100% automated in that output. We haven't, we didn't clean up anything, but you can see that, power being this, the mapping, 3D mapping area. Because we not only have this 2D land cover classes, but we also have, all the height information associated with it. And one step further that we can do based on this output is if we can go back to that resources tab again. And we collaborated with another open source company in South Korea to turn this 3D information into actual 3D visualization. So this is Indiana Hamilton County digital twin example. Yeah, this one here. So this is actually, we vectorized those building footprint and also did a segmentation of trees. So if you start to zoom in, you will see that actual buildings and trees and waters and all those other vector layer start to show up in this. And I believe, yeah, you can just do this in rotation. And once you zoom
Oh,
in,
nice.
it can give you the trees in it as well. And the input data set to generate this layer is not part of the 3DEP. This is the Hamilton County 2024 LiDAR data, which was, I think Hamilton County paid for it. They collected a QM1, 26 point per square meter LiDAR data, and 3-inch ortho imagery. And based on this, they generate this layer. But I work with the Hamilton County the GIS team to turn those in a vector layer into actual 3D visualization. Yeah, the point cloud is we only have one tile, so but you get an idea where
Yeah.
kind of things that can be done based on those resources available from the cloud.
Wow.
Yeah, I know, Jordan. We can spend hours to keep playing with it, but for the
I
sake
could
of
spend
time,
hours.
for the sake of time, let's go back to our resources tab.
All right.
I think this was the last, the custom build application that I have, but we have a tons of, educational material that we developed. We have a user manual. If you we have a, tons of, the video tutorial that is, modded to our website. We also have, a ton of, workshop example notebook available over there. So we are not going to go any of those, but those are for the, references for anyone else who might be interested in. Okay, with that, I said that I'm going to only spend about 30 minutes, but we ended up spending almost an hour. So let's see, these are some of the advanced stuff that we can do. But imagine that uh, you don't have any programming experience, But what I like to do with you is that I like to give you some template that you can just follow through, and doing some of those basic processes that I showed you yourself on your computer. So
Great.
if you can click that USGS 3DEP tutorial IPython notebook. So this is an open to public. Anybody can actually do it. And some of those requirement is you need to install Miniconda. I believe Jordan, you already installed it. For those of you who doesn't have installed it, just go there. You can just they have a very easy to follow instruction over there. Then the next thing that we need to do here is we need to create a virtual environment. So can we go to our terminal? Yeah, not this one, because we are not going to be using this Anaconda Navigator. So what we need to do is have this one in the back. Yep. Then let's type in conda create without the dollar sign. Sorry. Yeah, dollar sign does indicate that. Yeah.
Yeah, take it out after I put it in.
Go back to the terminal and paste that. Or it might be easier to type that in conda create dash n. Yep. Enter. And basically what we are doing is that we are creating a new virtual environment on your computer. So you want to proceed? Yes. So Y enter. Then we create it, and we need to activate this environment. So conda activate USGS 3DEP. Yep. Then you're going to see that at the front of your shell, it says the base, but now it says USGS 3DEP. It means that you are in base environment. Now you are inside this USGS 3DEP environment. So that's what we like to see. And we need to install certain packages that we're going to be using. So can you copy the first line, conda install conda forge mamba? This is another kind of package management system that is a lot faster than conda. So that's going to be something I install. Yeah, click enter. Then you may have to say yes. Okay, yeah, that one, that will work. Yes and enter. You're installing Mamba on your laptop. Let's copy the next line all the way to X-ray. Yep, to the second line. Copy and paste there. Enter. And this will install quite a bit of packages. So yes and enter. Now you're installing a lot of packages on your computer. And let's copy the next line, pip install d2spy geo. Okay, copy that one so that whenever we are done with this, then we're going to be installing that one as next.
Wow.
Yep, we're done. Let's copy the next line, pip install. Okay, enter. Since you're installing the data to sign Python module computer. And let's copy the next one, pip install local tile server. You're going to be using a leaf map to visualize some of the data product you're going to be generating. For that one, we need to install local tile server. That's what we are doing here. Okay, let's paste the next one. Okay, before we run Jupyter Notebook, we need to download this notebook to your computer. So let's create a directory. This is your home directory, right? So on your terminal, or let's click this in a download button. This one here, see? So let's create a folder called tutorial. Usually I like to have a non-white space in the file name. Probably this is a kind of coming from the background where the Linux where this white space is always causing some kind of issues. So yeah, tutorial, enter, paste that file that you just downloaded into the folder. Yep. Then can you copy this in a path? I don't know how to do it. Oh, let's go to the terminal because we need to actually go into that directory. So let's go back to the terminal. So we're gonna do cd change directory space and desktop, which is upper letter D, first letter B in the capital. Yeah, desktop. Enter. Can you do ls? This will list all the file. I'm hoping that. Oh, allow. I think you have a caps lock is on, but yeah, let's move into that directory. CD. So you have to do CD, then the cut paste that, change the directory. Yep. Enter. Can you do ls again? Now you see this strip notebook. And one thing that I want to make sure is that you are in USGS 3DEP in a virtual environment. You see that at the beginning of your command line, you see the USGS 3DEP, which means that you are in that virtual environment. And you are also in that folder where your Jupyter note, I mean the IPython notebook is in the downloaded. So from there, you're gonna type in Jupyter space notebook, py, sorry, Jupyter notebook space notebook. Okay, enter. And what you're doing is you're starting a Jupyter Notebook server on your computer, and this will open up your browser. So from here, you don't need a terminal. So let's go to the full screen mode. Where this spend it. Yep. Then open up that tutorial file, and this is exactly what you just looked at from the GitHub page, right? So if you have done any Python programming, this is Jupyter Notebook where we can have markup text plus Python code mixed up. So whenever you see that cell that has a number or this in a square bracket next to it, so if I just what I mean by this is that you see this number here, this is a code cell, meaning that this is your Python code. Whatever you see this cell without any bracket over there, that means that markdown cell where this is a simple text over there. So what we're going to do here is from the top, we are not going to do any coding, but you're going to be just play the click in a play button. So let's choose the first cell, code cell. You see the cell with the number 1. Can you click that? Yeah, now you select the cell, and if you stay there, and there is a button here, it says play. This means this one here, you are actually running that specific cell. You see that the estimate mark over there, they are still working on it. So if all the installation is correct, you should see no error messages, and this estimate mark should change into number 1. So whenever you are running this cell, it gives adds your number so that you can know which cell was run before than any others and etc. So this one you're still working. You see that it sends you to number 1. So can you click that cell again? and run it again. I think this one should go a lot faster. Yep. Now you see that, this is number two, mean that, hey, this is the second execution that I had. So this, the first cell has been loaded. So we loaded all the required module. So next one, we're gonna run this cell again because I'm just wrote a function so we can know what UTM zone that you belong based on the longitude value. So let's click that one. So it should run. So next one, we're gonna setting up an area of interest. So let's click that code cell, click run. Yeah,
Play or
play
run?
button. Yeah, play button. Yeah, sorry. Now, what it does is that it gives you a map where you can actually specify area of interest. So for this one, I want you to go to any location where you like to use an area of interest. And let's use about a block of residential area as an example. And we need to pick a location where we have a 3DEP data.
Yep.
So if you can click this in a rectangular, the button over here, this is the one that you can draw a rectangular boundary. So click and drag. Let's say this is the area that you're interested in. Uh, the bigger area to set, it will take longer. So maybe you can just set a little bit smaller. Otherwise, you may have to click the trash button, trash icon over there. Clear all. Then let's choose maybe two, yeah, that block. So that way, I mean, you can just set as large as you want, but just for the sake of time, we're gonna just do it this block. Or Jordan, can you expand this to be something like this so that we have some larger buildings?
Yeah.
Gonna clear that one. Yeah. Okay. So you set this in the boundary. This is your area of interest. So if you scroll this notebook down, so you have to scroll down outside of your, yeah. So let's choose the next cell, play button. This will actually get what is in a bounding box that you just draw on this in a leap map widget. So now this becomes your bounding box. And the next one, using this in a bounding box, we are going to be, you see that in a client, I'm connecting to this in a stack api.d2s.org. I'm saying,
Hmm.
hey, give me an item up to 10 item. And the collection that I'm going to look for is in a 3DEP. Bounding box is in a bounding box that I set. And they simply just play, the play button. Can you click play? Then this will give you, hey, I found one item in this area of interest that is from this AWS open data bucket, which is the Idaho. Is it Idaho State?
It is.
Yeah, Northern
Yep.
ID2 in 2019. Okay.
Yep.
So we need to pick item. So I just have next one has, and whenever we have a multiple item return, you need to choose the one that you like to use. But in this case, you don't have one. So Python uses zero-based index, so you cannot set that one because an item square bracket, this number should be changed to zero. So you see whatever index over here, this is the one that you like to use. You need to change that number to match with this one. Then from there, you
Okay.
just click play button. Okay. Now what we're gonna do next is you're gonna be downloading a 3DEP data over the area of interest that you define using your code. So let's play that cell. What we are doing here is that we just defining a polygon and all the 3DEP data this the bounding box is in WGS84, which is in a EPHG code of 4326. So let's play that button cell as well. But all the 3DEP data set using a spherical Mercator in a CRS, which is in an EPSG code of 3857. So what we are doing here is that we are projecting WGS84 to spherical Mercator. So let's play that cell, run this cell. Let's do this. And now we are going to be calculating what is going to be UTM zone number for that the area of interest that we are looking at. So let's play, run this cell, and run this cell again. This is
The
yeah.
the previous one
No,
or
you
this one?
already ran that one. So it
Okay.
gives you that this is UTM 11 North. So let's play that button again. This gives you the actual, the URL where you're gonna be pulling your, the AWS data, I mean, the 3DEP data from. So what you're gonna do next is that I'm gonna check whether, output folder and file name exists. If the already is there, you're gonna clear it out. If it is not, we'll just create folder. So let's run the next cell. So if you go back to your, the Finder, can you go back to your Finder? Then now you see that 3DEP data folder has been created, right? Because it was not there. That was the part that I was doing. Can you go into the 3DEP data folder? And let's go back to our Jupyter notebook. And let's run this cell. So I'm actually downloading this data using PDAL, which is the packages and managed by Howard Butler. So basically you see that, hey, this is the bounding box. I like to, write this. You see that, you already downloaded a point cloud there. So if you go back to your Finder, you're going to see a point cloud data downloaded to your computer based on location that you got. Do you have a cloud compare installed on computer by any sense?
I do not.
Uh, can we just install it? Because it shouldn't be that much difficult. Yeah, so let's go there. Click the link. I think,
Will it open a different window?
yeah,
Okay.
open a new one. Let's download, not the beta release, stable release. And you can scroll down. Cloud Compare Mac. Yeah, let's download that one. Mac OS binary. Yep. Okay. I believe this is the 15.6. I'm looking for the not the alpha version. Can you scroll down? I'm looking for the stable version. You see the Cloud Compare 232. Yeah, that one. Let's download that one. Download. And download button at at the bottom. Let's see downloads. Let's install that one. And Cloud Compare is an open source software where you can actually visualize point cloud. So there's a couple of things that I like to do with Cloud Compare. So let's run that. And probably you have to copy that code and paste into your application. So can you open up another Finder window? And can you click application on the left pane and drag and drop the Cloud Compare from other window to this application? I think you can just drag and drop the Cloud Compare only. You don't need to. Yeah. Not that one. And the leftmost column. Yep. Then double click, open. Now go back to the Finder where you have, Point Cloud downloaded, your desktop,
Yep.
tutorial, 3DEP. Can you drag and drop? Go back to Cloud Compare. Yes to all. Apply to all. Apply all. Yes to all. Now you have
Hmm.
the point cloud data downloaded from AWS to your local computer. So by
Wow.
default, they're showing you, I believe, the intensity value. And if you can stay there a little bit, and let me show you. If you move your mouse over this corner, you're going to see that in a point size. So you can increase the point size, decrease point size, and etc. Okay. So if you like to show the point color by elevation, you need to click Edit at the top. Going to Scalar field. Oh, you have to choose your point cloud first. So let's X that out. Choose that point cloud. Yeah. Go to edit again and scalar field and export coordinate to scalar field. Export coordinate. Yep. Click that one. Click OK. So basically you're adding, exporting your G value to your scalar value. It looks very flat because I'm pretty sure there's something extreme values. If you scroll down, this one here, scroll down, down, down further. Then you're gonna see this bar here. So you can move this one to the right. We will start to see. Don't go too much. And I think if you scroll this window a little bit, you're gonna see another one. You can just move this in at the red bar back. Yeah, you see that there's some noise point at the top. That's the reason why you're seeing this. But you can just play with this the color. Maybe you can just have red bar all the way up to this point because you can see the histogram over here. Yep.
Oh, yeah, red. I like red.
Yeah. And
There
now
we go.
in the main window, you can just rotate around to see. Yeah. You see a lot of noise point at the top, right?
Yeah.
Okay. And this is an example where what the code that I pre-wrote is not going to be able to filter out. Probably you and I can actually do some additional, the customization to generate the data product properly. But that's fine. So we downloaded the data from the AWS to your local computer over the area that you are interested in. So let's go back to our Jupyter notebook.
Let's see, where is it? Here.
Yep. So we just did this and visualize download point cloud using Cloud Compare. Now, what we like to do is that the point 3D data set does not come with color images. So I like to use the below code to colorize 3D LiDAR data. So let's go down to cell number 14. Click run. Yeah, play button. So this gives you all the NAEP item available over the area of interest that you chose. So you can pick the one that is close to the
Oh,
ear. So it was what year was it?
2019, I believe.
2019. I think one thing that you may want to check is you see the 2019, you see two of them, right? You
Yep.
scroll down. Can you click that stack browser URL from the item number 4? Yeah, click that one. And if you, yeah, this is the actual coverage of that one. Can you zoom in to see? Is this, yeah, this is the one that covers the area that you just drew, right?
Yes,
Yeah,
I
so
believe
we're going to use this
so.
one. Yeah, because
It's
this is
right
not the full
here.
resolution. So we need to choose this one. So let's go back to our notebook. So you need to choose item number 4. So cell number 15, update that one to be number 4 and play, run the cell. Then you're going to be clipping the native images to your local computer. So let's uh, run the next cell. Yep. And you are going to be downloading this is in a setting up the folder. So if you go back to your Finder, then you're going to see that native directory has been created. Go one directory up. You see the native data, right? That
Mhm.
has been created. Go back to
I'm gonna
that.
clean this up a little bit.
Yeah.
Oops, sorry. Okay.
Yeah. Go back to the code. Next one, we are actually clipping your native image to your computer. So let's click that. They're clipping in right now.
While it's doing that, I'm gonna continue to close these out. I don't think we need any of these anymore, do we?
I don't think so. No. No. Yeah, clipping has been done. So you see
All
that?
right,
That was
great.
done. And you go back to the Finder, you're going to see a tip
Yep.
images.
Okay, there it is.
And if you want, you can load into QGIS. We're going to skip that, but let's go to
We're
the
gonna
next.
We go to the cloud compare or we're going
No,
to
we're going to go
QGIS?
back to the Jupyter Notebook.
Okay, great.
So we're going to be actually displaying that native image we just downloaded. So if you just run the cell,
Okay.
you can see that, the map. You can just zoom in. You can see that, hey, this is the area that we actually, specified. This native image has a multispectral. They have a multispec, the near infrared band as well. So if you run the next cell, it'll show you, the near infrared color composite as well.
Ooh,
Okay.
nice.
And scroll down. This is the, using PDAL, we are actually colorizing the point cloud you downloaded. So you just, run this one. That one is done. So if you go back to your Finder and go to the 3DEP folder, you're going to see there's a new file that has been created. So let's go back to Cloud Compare. Then drag and drop that point cloud, the new one. Yeah, I think there. Yeah. Yeah. Apply all. Yes to all. And let me see why this is. Can you
Did I
create a
put the same one in? No.
let's click, can you click file? Oh yeah, you see the color one. Now you see it. You have colorized on a point cloud. So
Ooh,
the point information coming from 3DAP, color information coming from native imagery.
that's nice.
Yeah. So you can just colorize in a point cloud using these examples and over there. Okay. Let's go back to Jupyter Notebook. So, and I'm not going to do this, but if you want, you can create a fly through animation using Cloud Compare by zooming into certain. Let's do something really quick. Can you go back to Cloud Compare?
Yep.
And let's say this is one of the views. So if you do the Control V,
Okay.
oh, you know what? I think let me see.
The
Uh,
pivot point in here is interesting.
okay, let me see. There should be some. Is it Control B or something else? I don't know. I think we choose something else. Uh, Animation. Oh, can you click plugin at the top? Sorry. And the animation. Do we have an animation?
I don't
Yeah.
have that option.
Oh, you know what? You have to choose the, the actual. Oh, yeah. You may have to choose the viewpoint number one. Yeah. Can you go to
Okay.
plugin again? What is that? Can you choose the point cloud then? And doesn't let you do so. Do you see that viewpoint number one has been created over there? That means that
Hmm.
whatever view that you had, you created one animation. So let's add another viewpoint. So let's turn around the point cloud, whatever the angle. Do another Control V.
Fair enough. There's like a bizarre
Yeah, I think
pivot point.
you can just right click. Yeah, you can move it around, and you see that whatever the origin of the circle, that is your pivot point. So you have to move your mouse. Yeah, something like this. You just do Control V. Now you have a two viewport edit. So basically this becomes your key point. You go to plugin animation. I'm gonna say that duration to be 5 seconds at the top here. Yeah, or total duration to be 5 seconds because we only have two keyframe. And let me see, super resolution is there. You see that the alpha file where you are saving your file to. So let's click this one so that you can specify where you want to save it to. Does it?
That could be
Oh, is there any other window that is not showing?
maybe right here.
No, no,
Nope.
that's QGIS. No, let's just save it there. This is going to your home directory. So click OK.
That's okay.
Yeah, then what they're doing is that they are actually rendering this video to your local machine, and is that rendering is already done maybe? So can you go back to your Finder, go to your home directory? Oh, it is not generating. Hmm. I think that the idea, can you click the plugin and the animation one more time just to make sure? Animation. Oh, we have to do render, sorry. Okay, so to close it, you have to render it. Choose both. Yeah, yeah. The click render. Now they're actually,
Oh,
you
there
see
we
that
go.
they're actually rotating in the back. So click OK, then the click OK so that you can exit out. Then go back to your Finder. You see the animation, you could just play it. Oh, do you have any other uh, uh, viewer?
I don't.
Oh,
I might actually. See.
oh, you guys in CapCut? Well, yeah, I think that they may be able to load it here.
11 when you haven't logged into something for a while.
Mhm. Yeah, I've never used the CapCut before, so your home directory. Yeah, it works. So you can actually generate this in a flight through animation if you have those. So I mean, you only have a two keyframe, but you got an idea. You have 3D data, colorize it using NAP imagery. Then you can just have different the keyframe added. Then you can generate the flight through video out of this.
Awesome.
Okay, so let's go back to our Jupyter Notebook example. So what we like to do next is we like to generate the point density map. So now we're starting from point cloud. We like to generate some, the layer. So we just loaded a module. Next one, we'd like to set the, pixel size. We're using UTM, so unit is going to be meters. So I'm going to say, hey, I'm going to be using 1 meter resolution. So let's run the cell. Then I'm loading the downloaded the 3DEP data into Python. So if you just run the next cell, it will give you, whatever the coordinate, the upper left, the bottom right corner is going to be. Next one is setting up the number of rows and columns for the, output raster. So let's run the cell. Then we are actually doing a point density calculation in the next code. So let's click that one, play. We're just doing this, generation. And at the bottom, you're gonna run this cell again, 26.
This one?
You already ran, yeah. But
Okay.
yeah, the
So
one that you
next up.
haven't ran, yeah. I think the numbering is kind of messed up because you ran this one twice. Now, if you just visualize this, using the leaf map, next one, 27, you can actually see that this is in a point density map, but you see that there's a noise is kind of messing things up. But you got an
Yeah.
idea. You turn this into a raster data product. If you go back to QGIS and drag and drop, let's create a new project from the QGIS. And save it and go back to your Finder. Then go to 3DEP data. You see the example 3DEP density map. You just drag and drop. And you see that in extend value because there's some pixels has too many points. So you just go to property, pseudo band, pseudo color, and you like to use the color map to
Oops.
be different. Yeah. anything that turbo, and set the maximum to be 20. I think a 20 should be a good number. Yeah, click apply and OK. Then you can see the data that we got over here. So this is in a point density map. And usually the point I'd like to do here is that, hey, this 1 meter resolution is too fine or too coarse, but at least you are not seeing any empty cells. This could be a good data product that we can use to do, further data processing. So let's go back
And
to,
again, this is point density, right? This is how
yeah,
many points per meter.
yeah. So how many
Cool.
point per pixel, which is in a pixel is in a 1 meter scale.
Awesome.
Yeah.
Okay.
And if you like to kind of do more kind of things, what you can do here is that you can just exclude all the point that is in a classified noise. That can be something added, but I'm not going to worry about that in this part of the tutorial. But
Okay.
you now have a Python code where you can just do whatever you want. Let's create a digital surface model. Of course, this is going to be a little bit messed up because we are not filtering out any noise. But let's run this out. Now we just, generate this surface model. Let's visualize it using lip map. And looks like this, probably because I think I set the, min max value to be wrong. So let's go back to our QGIS. We'll come back to this one later. QGIS and drag and drop that DSM value that we created. So let's go to property. I like to look at the histogram first. Can you go click the histogram on the left? Compute histogram. You see the minimum value is somewhere around
30,
630. Yeah. Maximum you want to set probably 760
680.
or
Okay.
660. Yes. So 640, 660. Yeah. Now you can
Ooh.
see more like what you expect, right? And then we
Yeah.
can go back to our Jupyter notebook. I will show you why we are seeing red. Can you go scroll up a little bit? You see that the mean max value that I said is 211, 244. So we need to update this to be 630 to 660, which is the same value. Yeah. Run this cell again. And you see the exact
Awesome.
same. Yeah. And a lot of times you like to also know this elevation model. I like to call it the terrain model because we are more interested in terrain. So next part of the code, I'm doing the terrain model using some of the very basic um, PDAL functions. So we are not doing any fancy. We are only using the classification of two, which means that hey, I like to use only ground point, and I'm just doing inverse distance weighting. So this is in a very simplistic way of generating DTM. Of course, there are more complicated ways of generating DTM, but you actually run this cell, right?
I
So
did.
yeah, let's go back to QGIS and let's try to load that DTM that just really created. Gonna see the DTM loaded over here. So you're gonna see that a lot of empty spot over there because those are the buildings where we don't have any ground point. So what we like to do here is that we like to fill those gaps. So let's choose that DTM that we created. Let's click raster at the top, raster menu, go to analysis and fill no data. And basically, this is going to be the one that will do the interpolation. So what we need to do is, can you scroll down? And we need to set the file to be saved. So let's click this in the three button there. This one here. Yep. Save to file. Then go back to the desktop, the directory where we are just saving all the data. Go to 3DEP and choose the DTM, but add a here over here underscore field. No, as a FILLED, sorry. Fill the gaps, the field. And we need to make sure that choose the, this to be TIFF because, the code has says a TIFF with a double F. It really doesn't matter,
Okay.
but yeah, click save. And this is a key bug in the QGIS data. This window disappears, so we haven't run this, the peel operation yet. So can you, uh, using your three finger or see the all the window?
What was that?
Yeah, can you do this one again? Show all the window. This is the one that is in went to
Oh,
behind. They haven't actually run it yet. So click run from here. Now this is doing operation. Now we can close it. Now you have this in a digital terrain model that has been, generated. So you can see that,
oh, nice.
yeah, that we
Okay.
fill those in a gap. Okay. So from there, what we're gonna do next is go back to Jupyter Notebook. Let's, that's the part that we did, and let's, load that, DTM. So I think that we need to actually check the elevation, see that I set the B min and max value to be 211 and 218. So we may have to get that, meaningful number from uh, the QGIS. So that one was for the DSM. So can you go back to the QGIS so that we can get the histogram with DTM? Yep, histogram. So 630, let's do 635 to 638, right? I think that should be a
Okay.
pretty good range. So 635 to 638.
And why the specificity there would, because 630 to 660 would have captured that range, but
Yeah,
why this level of detail?
yeah. So if you just run the cell, you will see that,
Ooh.
you see that the empty hole. This is before we filled, and use the same value. If you scroll down, change the Vmin max value 635, 638 here, and run the cell. Then now you see those in a field in a digital twin
Awesome.
model. Okay. So what we are doing next here is that we are going to be generating a new point cloud, which in a height value is not above ellipsoid, but, or above geoid, or whatever the reference in the vertical datum they use. But we just replace everything above the ground. So this is the code that we are doing. So we just run this cell. This is it. And run the next cell. We are actually saving this newly calculated height value to as a new file. So now if you load that, you see that example 3DEP data, can you scroll up a little bit? Scroll up. Example 3DEP data normalized height.lag file. This is something we just created new. So if you go back to cloud compare, then drag and drop that new LAG file, the last one, example normalized height. Yep. Let's do apply all, yes to all. You see the new point that is showing at the bottom?
Hmm.
Because everything is above ground. So if you can just turn off all the other point, and if you just choose that point cloud, we're gonna add that height value. So again, edit, scalar field. Can you go to the edit? Same trick that we did. Add coordinate to the scalar field. Yep. And okay. Now they've been added, but you can also change that the min max value at the bottom. So move that red, not that red one. So you can just see that now everything is in the flat. So if you just zoom in, you may have to use right click to move up. Yep. You know, this is in a relatively flat area, so you're not going to see that much of difference. But if this is in the hilly area, you can see that everything is flattened out. So we actually eliminated those topography effect from the data. Okay. And next one, go back to Jupyter Notebook. Then next part here is that we are going to be generating normalized digital height map because now we have a new point cloud where all the height values in above ground using the same routine that we used to digital service model. We just apply to this normalized high point cloud data. So if you just run this one, now we just
And so why did we take out the terrain value?
because we like to know, for example, if you like to measure the height of the building,
Oh, okay.
this is going to be in reference to the ground. So if you like to measure height of the trees in reference to the ground,
Awesome.
so
Okay.
we are flattening out all this in height the value so that they're reference to the ground, so that everything is on the ground. So it's going to be a lot easier for us to generate this following data product from that normal
Awesome.
height data. If you just run this cell, yep. So you you already ran it, so let's run this cell. Then you're going to see this is a normalized height data product. So you see that now you don't see that the elevation change anymore. Everything is in reference to the ground, and you see a
Wow.
lot of those noise over there. But you can easily include more filtering in the middle of code where hey, if point is classified as a noise, then we just skip it. Don't just assign the value. And we
Yeah.
can just do additional step. But you just went through in hour and 30 minutes. You actually went through the whole process, how to download do that data to your computer and generate various different product. And some of the example that I showed you earlier, that we're using very similar kind of pipeline to pulling the data set from the AWS and Microsoft Cloud. Somehow mix them together to do some data processing. And once we generate this data product, we just make those product and process data available to the customer.
Awesome. There's a whole world of possibility here, like you just mentioned, calculating building height, tree height,
Yep.
canopy.
Yep. And one of the new kind of research development that one of my PhD students is working on right now is that are you familiar with a geo-foundational model?
Yes.
So, there is a lot of big players, trying to do it. NASA is doing it. So they published that,
Mhm.
the Purdue 2.0, which is a new foundational model that is developed based on, Landsat and Sentinel-2 imagery. And Google Earth, Google also released that Google Earth foundation embedding model. So this is another foundation model they just released. And one of my PhD student, his PhD topic is that we like to develop foundational model for 3D because now we have all these 3D data set available in AWS. We
Yes.
have a huge amount of 3D data set available, but if you can train this in a foundational model so that we can learn from it directly, then we can do um, based on this in a pre-trained model, we should be able to do a lot of other complicated tasks a lot more easily. So that's one of the kind of most exciting research topic that my research group is pursuing at this moment right now. He tested with some of the test location, and we are seeing very promising results. So you might see that in a 3D foundational model, we have to still come up with a the catchy name for it. We don't know what that is going to be yet, but you may soon see that, hey, there is going to be geospatial foundation model that is based on the USGS 3D data set.
That's exciting.
Mhm.
That is exciting because elevation uh, and terrain, I mean, they drive everything else.
Yeah,
Right? It's what sits at the core of it. That's awesome, Jinha.
yeah. So now you have this code. You can just apply this to anywhere in the United States. You just simply draw
Yeah,
that in a boundary. You have all the code to generate this kind of data product. And this is always the first step that we do, but I've shown an example of other more complicated example where we just pre-training model but pulling the data set from the cloud. So this is kind of entry point, but the sky's the limit. There are so many other things we can do with this kind of pipeline.
it's really exciting. What kind of work have you seen so far out of your students or other folks who are participating in using this pipeline?
So the most exciting part is the one that we did the urban 3D mapping example that I showed you. We have Cook County, New York, Denver. One of my students who graduated actually last year, he published in a good paper where he's been applying this to do, very high resolution urban 3D mapping, using that outcome to understand the urban heat island effect. So
Hmm.
what kind of landscape, configuration in urban areas is impacting, the temperature variation throughout the year. So he was using eco-stress data set from ISS, space station. We have a thermal measurement throughout the year in different time of the day. So he just did that 3D urban mapping using 3DEP and NAP imagery, and trying to understand the impact of this 3D landscape configuration for heat um, variation in different season. So I think that is one of the area where we just had a most recent research and update. The other one is, like I mentioned earlier, using developing this geofoundational model using 3D data is one area. Another area that we are very interested in is using this 3D data set to do urban tree mapping. Because right now, I showed an example of the Cook County area where you can see where the buildings are, where the trees are, but we are not separating those individual tree out. We just have the pixel that is classified as a
Yeah.
tree, but it doesn't necessarily say that, hey, where is one tree yet? So one of my students is working on actually using some of the the tree inventory data set that is collected by a bunch of scientists, and how can we use those information to train our AI model so that we can do actual individual tree segmentation in urban area, so that we can actually know where those trees are. And the good thing about this tree type is we have a multi-temporal aspect it, so we can also track
Hmm.
how many trees are where and how big they are. We can just get this kind of information summarized at scale.
What's really exciting is when
Mm.
you pull the thread through all three of those use cases, right? You have the heat map and the foundational model and the trees and the buildings and how everything's actually oriented, plus
Mhm.
the time element. And you can start to understand, okay, how does the configuration of our cities impact energy costs,
Yep.
the way that we move around,
Yep.
the way that we make design and build decisions.
Mhm.
How do we actually create efficient, livable spaces that work for people? Uh, and you can start using those foundational models to rinse, rather, lather, and repeat across the whole of the United States, not just the specific areas that you pre-processed, right?
Yeah,
Is that kind of where
exactly.
you see things going, or how do you how do you expect people to actually? Because it's one thing to study something, and it's another thing to use the results of that uh, research in the real world and apply it.
So I think we spend a lot of money to build this the big database, but uh, although this accessibility of this student data set has increased significantly, especially a lot of good work done by Howard Butler for sure with the AWS team. I don't think we are taking full advantage of this potential of this student data set yet. And
Uh,
by making this data set available is not enough, but you know, providing this kind of training material to large group of people, so that not only my research group can take advantage of these great resources, but all those younger generation, next generation to come, they have all the smart mind, and that they can do something we never thought of that is possible. I think I always make analogy to this research science all the time, and I like the YouTube analogy so much. I think I already made this in analogy in this team meeting earlier. When the YouTube first came, you know nobody thought that, hey, you can make living out of eating something in front of your camera. But if you look at right now, actually there is a quite good number of people who's making living by eating something in front of a camera. They can making a ton of money. And who have ever thought about using this kind of video platform to do those kind of stuff? And those examples that I mentioned earlier, urban 3D mapping, urban tree mapping, terrain modeling, those are some examples that I know and I'm interested in doing something, innovative. But there is going to be so many other things we never thought of that isn't possible, that other creative people will come up with a new way of utilizing this data set to do something crazy.
I love that.
Yeah.
Yeah, because then the innovation happens at the nodes. You never know where it's going to go.
Yeah.
And the beautiful thing about this is, I mean, there are a lot of platforms out there that make it really easy to visualize the point clouds,
Hmm.
to the DSM or the DTM,
Hmm.
but it's one thing to use someone else's pre-processed data, and
Hmm.
it's another thing to be able to take the raw point clouds and the raw data and to transform it and work with it on your own for your own specific use case in a
Yep.
way that's transparent and you know what's happening. And so, oops, that's why I really love
Yep.
this project that you're working on, Jinha, because it really opens the doors. Uh, I mean, like you mentioned, I've never worked with a raw point cloud process from like myself as an individual
Hmm.
working at the module
Hmm.
before, and we did that in less than an hour and a half, right? Most of my experience has been working with pre-processed data,
Yep.
seeing those products and then trying to apply them. But now I have a whole world of potential open to me for, oh, I need it tweaked in this certain way, or I need to analyze it in this other way, or I need these numbers to fit this specific use case. And now I have a workflow at my disposal to do
Yep.
that.
Yep. Yep. I mean, that's the
Awesome.
beauty of this in open source, where we just share everything and we all benefit from each other. So I'm really excited about this, and most of the work that we've been working on is limited to our group only, but having this kind of the you know training workshop being recorded and shared with a larger group of audience, I'm pretty sure that there's going to be a lot more smart people than we are. Will come up with a crazy new way of utilizing this data set for something else.
Absolutely.
Mhm.
And so there's it's one thing to have innovation and ideas and applications happen at the nodes. How would you recommend people bringing that back to the community, sharing their experiences out, sharing their use cases out? Is there a place that you've made available or that you would recommend people, post their projects or their products or showcase their work so that everyone can learn from uh, their use of your pipelines?
I haven't thought about that, but I think this is very important, part that we need to think of. But maybe this is not any prepared answer or anything, but this repository that I just that made it public, do the tutorial. So if there's anybody who has a crazy new way of using this kind of data product and willing to share your pipeline, just send a pull request to that GitHub repo, and I'll be more than happy to compile this into in a centralized place where others can take advantage of those in a new pipeline or whatever their the processing pipeline needed.
Awesome.
Mhm.
Jinha, this has been awesome. I really appreciate you taking the time to walk me through this today
Mhm.
and your patience as I fumbled over keys and terminals. But I mean, I don't do a whole lot of work in the terminal, and
Mhm.
you made it easy, and this
Mhm.
tutorial made it easy. So I really encourage anyone, regardless of your technical capacity or experience, try it out, get your hands dirty, and you can all the only thing that you could do is fail and learn, right? So
Yep.
um, is there anything else you'd like to leave the audience with, or anything you'd like to point them to help expand their ability to utilize this 3DEP data that we both agree is so foundational?
Yep. So if you have any questions, feel free to reach out to via email. And Jordan, if you can just pull up another tab so that I can give that my research group website. So it is called GDSL, Geospatial Data Science, gdsl.org. Yep. That's my research group website. You see that in a photo of this still need a lot of work. This is the photo of the most recent gathering of my research group. So those are the members that I always say that I'm just cheerleaders, but all the brain is behind me in those photos.
Awesome.
If you have any question, you can just check this out. And there is also contact tab over here. You can actually send me a message using this one, or you have email address. My first name Jinha at Purdue.edu. That's the email address. So
Awesome.
please reach out to me.
All right, Jinha, really
Mhm.
appreciate the time and looking forward to seeing what people do with these pipelines that you've made available.
Thank you very much. Thanks for your time, Jordan.
All right, I'm going to see if I can stop this recording.